Okay, I am now recording and I will get started. Oh wait, let me share my screen here. Okay, I should do. So let me know if you can't see that in the lounge chat. But I think you can, so. All right, so today we're going over network traffic analysis. It's an interesting way to categorize this kind of hacking work, but basically, traffic like network traffic analysis involves going over the stuff that you've been sniffing across the network. So we're going to talk about all of that today. We're going to have a little crash course in networking and how networks work. And honestly, this subject is huge. It's absolutely massive. There's so much to talk about when it comes to web protocols. There's so many tools developed out there for all kinds of sniffing and things like that, network sniffing and capturing packets. There's a whole lot of details I'm probably not going to cover, and maybe even won't be able to cover the topics that I am covering effectively enough. So just bear with me, and if you guys have important things you want to share, I'll give some time at the end of the presentation component for you guys to share your deep insights on network traffic analysis and understanding network protocols. So today we'll be doing a presentation. It'll be a little longer than last time's. We'll probably go about 20 or 15 or 20 minutes for the presentation, and then we'll do a workshop together. I did record the log analysis workshop. I just haven't posted it. Oh wait, not the workshop. I recorded the presentation, but didn't post the video yet. Okay, so another thing I wanted to mention is that this weekend we're doing, if you check out the events tab at the top of the Discord, we're doing Def Camp. Now, not everyone can compete in this one like we did at the last CTF, but we'll be live streaming throughout the thing, so you guys will be able to jump in at any time and talk to us about what we're doing. Sometimes there might not be any of us working on any of the challenges because the competition's going all weekend, but anytime that we're on, please feel free to drop in and chat with us while we work on solving stuff, and it's fun. It's fun to just try it out. So, okay. Also, if you haven't signed up for Magpie CTF, it's at the end of reading week. Definitely jump on that. That's something you don't want to miss out on. It's going to be really fun. It'll be a good way to introduce yourself to other topics and just honestly enjoy hacking. Okay. So you're probably wondering, why should I care about network analysis, right? Why should I care about analyzing traffic across the network? Well, I could counter that question with a few more questions. Why would the FBI tap wires? By extension, why would the NSA be so interested in everyone's information? Why would they be so interested in your communications across the internet and your communications within your local network? Why would they be interested if hackers shouldn't be interested? And then again, on another extension to that question would be, why would the Allies have been interested and put so much effort into spying on the Axis forces? Why would they have worked on communication, splicing, capturing encrypted messages and decoding them, and honestly putting insane amounts of effort into cryptography? And then why would you have a router or a modem if you shouldn't care about networking in general? So basically, the answer to that question, and hopefully I didn't sound too, snarky when I was asking those rebuttal questions, but the answer is that anything that you do on the internet gets packed up and sent across the internet. So networking is the core of of internet entirely. Everything that you do, whether it be on your phone, whether it be on your computer, gets transmitted across the internet in some way, unless your device is completely offline. which virtually nothing is these days. Even Internet of Things devices have communications across the internet. So it's important to understand to some degree, if you're going to work in any IT or security field or even software, it's important to understand networking, and this could be a valuable skill to have. So yeah, and not everything is transmitted across the internet in plain text. So even your like those passwords, email addresses, things above, most of the time that stuff's going to be packed and packed and packed under layers of encryption, so you won't have to worry about that kind of thing getting compromised for the most part. Okay, so in order to understand network traffic analysis, you have to understand the internet first. So this is the beginning of our brief crash course in networking and how the internet works. So what is the internet? Well, I was going to try and bring up a meme where this I think is a United States ambassador or something like that talks about how the internet is a series of tubes. And honestly, it's hilarious to say that the internet is a series of tubes, but it's so close to the truth. It really is a series of tubes. It's wires and fiber optic cables and now satellite transmissions, which is a newer avenue of the internet. And there might be something I'm missing, but ultimately it's copper cables and fiber optic wires. Yeah, so that's another thing we're going to talk about too, is how diverse and crazy that network can really be. Like, it's just insane how quick it is and how huge it is, the internet specifically. I hope you love the GIFs that I put there too. So how does your data travel in the internet? Well, your data gets packaged up. And most of the time, it's like they take your data and they put it in an envelope, and then they put that envelope in another envelope, and that envelope in another envelope. So this only shows 2 envelopes, but usually it's getting packed within 4 or 5 or even more envelopes as it traverses the internet. So one packet of data is one segment of your data. So if you're making some kind of like a web request, or you're streaming a movie or something like that, that movie gets chopped up into tiny packets and packaged up neatly into these bundled packets and sent across the internet. And in the case of a movie, you get hundreds of thousands of packets streamed to you constantly over certain protocols, which is kind of cool. So the internet has often been modeled under the Open Systems Interconnection model, the OSI model. It's personally my favorite way of trying to understand the internet. Networking in general, not just the internet, but typically what happens is you have your computer, you make some kind of a request on your computer, whether it be through a web browser, which is probably the best example, and then your request gets packaged up. Usually these 3 layers, application, presentation, and session, are considered one. It's just sometimes easier that way, but in a web interface, these 3 are pretty separate. And so your request gets packaged up, gets brought down to the transport layer, then packaged again to the network layer, then packaged again to the data link layer, and then packaged throughout its journey multiple times back and forth between data link and physical and sometimes network. And then, it'll make hops, and we'll go over that too, as it traverses the internet. And once it reaches its final destination, it's going to get unpacked, all the way up till it's processed. And then that message, whatever the reply will be, will go through the same process and come back. So that's basically what I hope this looks good. I hope this is kind of clear. We'll see later on a little bit more about how those packets look, and how they get packaged down and back up. And so we'll kind of talk about packet contents right now. So normally a packet will have multiple layers, like we were talking about. your physical, your data link, your network layer. Those are the three that are pretty much always going to pop up or about the same way in whatever packet sniffer you're using or packet analyzer. And then once you get past those first three, it's going to start to change based on whatever packet or whatever application that packet belongs to. So in this case, the transport layer is showing a UDP protocol. It's usually UDP or TCP, but there's so many other kinds of transport protocols. And then you've also got your session stuff. And in this case, this is a DNS packet. I've redacted some information. I don't think it matters if you see the local IPs because you can't access those. So we'll talk more about this stuff too. And once we workshop, you guys will get hands-on practice with that stuff. So network protocols and packet structure. Again, I put this picture in here so that you guys can see some examples of the different protocols that are used across each of the layers. Like in your application layer, you're going to be using HTTP, file transfer protocol, DNS. I don't remember what SNMP stands for, but and then Telnet, which is outdated, old. And then you've got your secure socket layer and your transport layer security. These are additional security features. SSL is for your HTTPS connections. TLS is an additional application. I guess it's presentation layer. I didn't realize. I thought it was application. But anyways, I won't get into each one of these, but these are some examples of protocols that are implemented in these various network layers. Okay. So yeah, if you're ever going to Google, like let's say you have a packet and you don't know what the protocol is, like you can usually look at the different layers in your analyzer and Google whatever that protocol is based on the layer that it resides in, and you'll get usually more accurate information. But okay, so here is that picture of the top-down approach for packets and how they get further packaged the deeper they go. Sorry. So I don't know if you can see this well, but let's say you've got your application layer. There's headers that are attached in this packet, right? So you've got a header and then you've got your data usually. And then when it goes down, that packet gets wrapped by another packet, usually with a header that points to the end of that file or that packet. And the header contains other useful information. Like in the case of TCP and UDP, it'll talk about ports and stuff like that. And there's so many variations of what these headers can look like, but typically they'll contain really similar information. And then this will get packed once it goes down into the next layer, and a new header is attached to it. So usually, your header for the next packet will be in front, and then the data section will contain the entirety of the previous packet. And then it just continues to do that the deeper it goes. And these packets get a little bigger and bigger as they go along. Then they hit the data link or physical layer where they're transmitted into binary. And routers have ways of talking to each other. Any wired connection will have a way of transmitting that data from one node or router across the medium and then into the next, and so that will have a way of understanding that binary as it traverses. So in the case of copper wires, it's it's a super interesting subject to get into the way that electrical impulses traverse a wire, and there's entire scientific topics about whether it's like actual electrons going back and forth between the wire, or if it's like electromagnetic waves traversing the wire. And so that's a cool one. There's a Veritasium video on that, and I recommend you guys Google that at some point because it's a really fascinating subject. And then there's fiber optic, which transmits light across really tiny tubes. That's pretty cool too. We'll talk more about that as well. So your packets, when they traverse the internet, this is a really wild and complicated subject. And I would say that I have a very surface level understanding of this. But essentially, what you'll be dealing with is the BGP, or Border Gateway Protocol, which is the protocol that internet service providers use to transmit data between each other. So normally when you're making a web request, your data doesn't just go straight to that server, right? It will go from your computer to your router, then from your router to the next hop in the ISP network that you belong to. And then from there, it's going to traverse within the ISP until it reaches the border of the ISP, and it will communicate with the next internet service provider, and then it will traverse that ISP until it reaches the next one that's closest. And there's all these routing tables and stuff in each one of those ISPs, and every one of their BGP, I don't know what the proper term would be, but servers, I guess. And so, or router or switches, and then they traverse until they reach the destination, and then it makes a similar trip back. So it's interesting, right? And I included this picture because it shows a house, which is what most of us are in right now. And then it's going to go through your ISP, and then through the BGPs, and through the and you can also see that, like, there's phones connected, but I don't think that that's really working on the same network as the internet. I think that has its own. And then, yeah, that's how it goes. And then I wanted to talk about this too, because this is insane. But if you've ever wondered how, if the internet is really just wires, then how are we able to, connect to a website in the UK if we're in Canada, right? Well, there's huge cables being ran across the ocean. If you don't believe me, Google it, because I think they ran the first intercontinental cables in like 1930 or something like that. It was early, and they were copper cables back then, and they encountered some really interesting problems because they thought that electricity traveled in a certain way through a copper cable, but because they had a fundamental misunderstanding of the way electrons transmit energy across a cable, they had to redo the entire way that they set up copper cables across the ocean. But eventually they switched to fiber optic, and this is kind of like a picture of what those fiber optic cables look like. And then this is a picture. Apparently Mexico's updating their intercontinental cables, and this one looks kind of like a cactus, so I thought that was kind of a cool picture to include. But here's a map that includes an overview. I think this belongs to a website that you can go and look at, and it shows all the intercontinental cables, and I don't think that that's the exact path that cable follows, but it just shows how many cables there are and how many land masses are connected. And honestly, I think it's insane. It's so wild that we literally just ran cables across the ocean. That was our solution. It reminds me of how Google Maps, they were like, how are we going to get, street view on the world? Well, let's just buy a whole bunch of cars with cameras and drive the entire planet. Not necessarily an elegant solution, but they went for it. Oh yeah, so sorry, I haven't been looking at the chat, so I will respond to Sandkalp's message right now. So, welcome. Super happy to have you here. Check out so I'm live streaming right now. I'm kind of going over a presentation. We're talking about network traffic analysis right now. And I'm just giving a kind of a crash course on how networks work. And so right now we're doing the presentation portion, and in probably like 10 minutes we'll be doing a workshop where you get to get your hands dirty with some network traffic analysis. So just hang tight and enjoy. I hope that answers your questions. Sweet. Okay, so hops. You may have heard me use this term a little bit. As your data traverses each router in its destination, or in its journey across the internet, it's going to make hops between each router, right? That's what the That's what the terminology means, or is for. So there's utilities you can use. The one that comes built into most Windows applications is traceroute or traceRT. And in this case, you can see that I did a traceroute to Google, and this is how many hops my packet made from my house to Google servers. So it made 10 hops. And then I did a little experiment and did a traceroute to the government of Russia's server, because I knew that that would be Intercontinental, and I wanted to see how many routers it would hop between. And it turns out it made 30 hops to get there. So there is significantly more routers and ISPs between my house and the government of Russia's servers all the way over in probably Moscow. Thanks. Oh, I guess Rashab's already left. I was going to tell him thanks for popping in, but yeah. So that's just kind of a cool thing to play with at some point. It's kind of interesting the way that this works, but if you do seed labs, they're basically just these online workshops you can do solo. They're really hard to do if you don't know anything about them. But honestly, if you really just sit there and bang your head against a wall with them, you will learn an insane amount. And in one of the seed labs, you write your own traceroute program. And it's kind of cool the way it works. It's much more simple than you might realize. But it teaches you a thing or two about packet traversal. Okay, that's a lot of trivia. I give you guys a lot of information. When you're doing network sniffing, you're probably never going to be sniffing anything outside of your local area network, which is the LAN there. If there is a way to sniff traffic outside of your LAN, I'd like to know about that, but I don't think that there really is a way to do that. Usually, network sniffing requires kicking your network card into promiscuous mode, and if you don't, like if you're running a VM or something like that, it can be really hard or impossible. But if you're, I don't know, like I think my laptop can go into promiscuous mode. So yeah, either way, you need to have root permissions in order to do that. And I don't think you really need to worry about it most of the time. Because if you're able to if you run Wireshark and it's collecting packets, then it's probably working. Okay, so most of the time your local network IP addresses will pop up as like a 192.168.whatever. That shows that it's all the IPs you're seeing are local machines. As well, you'll see 10.0.whatever. And your router or your gateway usually ends with a 1. So you'd see like 192.168.0.1. That would be your gateway. 10.0.0.1 gateway. Okay, so let's talk tools. There are lots and lots of tools. There's so many available. There's some extremely powerful ones that are free to use. Wireshark is probably one of the most known and most used, but there's tons out there that allow you to capture or dump packets. TCP dumps TCP packets, etc., etc. I'm sure I'm understating its capabilities. Ettercap is another thing that people use for capturing packets, and BetterCap is a version of Ettercap that's implemented in the Go language. And I've personally used BetterCap a few times. It's pretty cool, but I haven't used Ettercap. I also haven't used any of these three, but I saw that they were recommended, so I figured I'd put them in the list for you guys to look at. And another thing, too, to note is that you don't just have to use a tool. You can write your own sniffing and spoofing scripts and stuff like that. There's plenty of libraries out there for it. You can basically pick a language you want to work in, and there'll be a library somewhere to use for networking. Usually it involves creating sockets and doing some sniffing and spoofing, as they say. Escapees, what you can use in Python. It's kind of slow because there's a lot of overhead because Python is like that. I personally have done PCAP and the sockets library, and that's built in C, and it's very fast. And that's kind of just a breadth for you to understand so that you can know what to look up later. Okay, we're here. It is workshop time. So I have a capture file that I'm going to drop in the lounge chat. If you don't have Wireshark installed on your computer, I recommend you go install that now. I'll be here to answer questions on how to get that installed. If you're on Windows, if you're on Mac, if you're on Linux, there's ways to do it. If you already have it installed, then you can get started. I'll also drop the questions in the lounge chat. And I guess we can... I'll let you kind of struggle with it for a bit, and then I'll show you just kind of some basic things with Wireshark. And then let you struggle some more, and then give you some answers as we go along. All right, so I'm going to stop the recording here and